All right, I think I'm ready to go. Unfortunately, I had to restart my computer right before I did this, and so all the things I had set up weren't set up anymore. But I think we are ready. So thank you all for coming out. I'm going to be sitting down. Usually during a presentation, I'll get up and move around, but here I'm going to be sitting down because I need to be at this computer sort of driving things, pushing them forward. So the workshop here is an introduction to programming. I forget, I gave it some longer title. Here we go. An introduction to programming, Python and spreadsheets. And so the basic premise of this, I guess I don't need this schedule anymore. We'll come back to, I know there's a request for BTS, we'll come back to BTS later. Everybody loves the mic drop. So the basic premise here is, this comes from the fact that I am relatively new to software development, and so I've gone through the process of teaching myself to program. And one of the things that I've learned is that if you're learning to program, there are three things that you really need. And let me make this a little bit bigger just so it's clear. One, you need some sort of a programming language. That's should be hopefully is obvious because you can't program without a programming language. Two, you need some sort of a tool to make use of that programming language. And so you can use a text editor. How many of you are familiar with a text editor, or what a text editor is? Yes, okay, most of you. And I'm sorry, I don't know everyone's background. I know like some of you are like college, university students who are studying computer science, and others come from different backgrounds like I did. So you need but you need basic tools to use that programming language. But then also, to really learn how to program well, you need some sort of a project to work on. And so the point of this workshop is to try to give you all three. And so the programming language is Python. The tools that I'm going to be using, the main tool I'm going to be using is the Jupyter Notebook. And if you were at yesterday's keynote, you might have heard from Kara Willing, who talked about Jupyter Notebooks. And I believe there was another talk yesterday, about, I think another workshop yesterday about Jupyter Notebooks. And then there's also going to be an open space later about Jupyter Notebooks. So this is, if you haven't seen one before already, this is what a Jupyter Notebook looks like. And I'll demonstrate some of the basic features of it and how it can be useful to you. One of the nice things about a Jupyter Notebook is that it's a programming environment that is available free of charge. If you can install Python on your computer, you can install Jupyter Notebooks on your computer, and you can use them to help you. Let's see, actually, I will go back here and, no, won't do that. So it's just a matter of typing Jupyter Notebook. And so this is all the service-side stuff running, but it pops up this thing in your browser so that you can now type code into your web browser. This is some markdown text that I've done, but you can now type code here into your browser and it will run. And so you have a programming environment already. So that's what we're going to do here. So that's the basic premise of the workshop. So the next thing that we're going to do, I don't want to do that, is we're going to take a look at our data and explain the problem that we're actually working on. So if you're programming, you're trying to solve some sort of a problem. So I'm going to explain the problem that we're looking at here. And then there are a number of different code files. And we'll look at each of those. And the workshop, it's intended to be a beginner level workshop. So I'll be explaining what the different bits of Python do in each of these files. And so that, to make it clear what's going on, but also to explain how we're solving this problem. And then we'll try some things in the notebook. Like I said, with the Jupyter Notebook, you can just type live code into it and get results. And that's a nice thing about it, especially as you're learning to code. And you can see the results live. So that's what we're going to do next. And this I thought was interesting. Jupyter. So, I mean, you've seen, this logo, the Jupyter Notebook here at the top. Do I have that little? Oh, the laser pointer's gone. You've seen this name Jupyter for Jupyter Notebooks, and it's just a thing that just most people might not be familiar with. It's not super important, but I thought it's interesting. Like where the name Jupyter comes from and why is it spelled with a Y. So these Jupyter Notebooks used to be called IPython notebooks, and so the name Jupyter comes from the languages that we used to build it. A language called Julia, and then Python and R. Those are the languages it was primarily built for using, and so that's where the name comes from, Jupyter. It's also a planet. So first we're going to take a look at our data and we're going to see what it is we're trying to do. So, because if you're doing any sort of programming, you need to understand what's called the problem space. Like, what am I trying to do here? What am I trying to work with? And so in this case, we're going to look at a spreadsheet. So has anyone not seen a spreadsheet? Or anyone new to spreadsheet? Yes, no? Okay. Oh, you're new to spreadsheets? Okay, well, that's fine. Those spreadsheets, they're often used in businesses for doing computations, sometimes for storing data. Before I was a software developer, I was an accountant, and so accountants use spreadsheets a lot, but really almost anyone who's keeping track of anything can use a spreadsheet. So for instance here, this is, I was working on, I was working on a more fun example, and so this is a list of different K-pop artists, and then this is the group that they're in, and then this is their gender, and then these are their positions in their group. So these are the things they do for their groups. And so I was working on a more fun example that used K-pop artists, but I haven't gotten around to finishing that. But maybe one day I'll finish it and bring it back to the DR and let you all enjoy that. So here I have a more boring spreadsheet, unfortunately. But this is a spreadsheet based on a real spreadsheet that I used in a prior accounting job. So this is timesheet information. And so we've got a range of people. Some of you are a little older. You might probably worked in jobs before. Some of you are younger and maybe haven't had a job. So in a lot of companies, what happens is you have to keep track of your time. And so in a professional services company, like an accounting company or an engineering company, they want to know, okay, well, how much time did you work today? And then what sort of things did you work on? And they want to keep track of that information. So that's what this is. I'm just going to stand up here. So here you have, and so each of these rows represents a certain amount of time for an employee. So you've got the employee number here. Each employee, what do you use here in the DR for, like, everyone has like some sort of identification number or something? In the US we have social security numbers. Okay. Okay. And so in most companies, you'll also have an employee ID number. So each employee will have their own individual ID number. So this is the employee number. This is what's called a cost center. This is a division in your company. So maybe you work in these sort of together here. This division, these are more like global divisions. So maybe 1,000 is for North America, 2,000 is for South America, 3,000 might be for Asia. But here, this cost center, this is the specific group you work in your company. And so maybe you work in the marketing department or in the accounting department. But then an accounting department might be broken into two different types of accounting. So maybe there's financial accounting and tax accounting. So financial accounting might have one cost center number, and then cost accounting might have a different cost center number. So they're more like the subunits in your company. And employees are usually tracked by those. So here's this person. They work in this specific cost center, so maybe they work in the financial accounting group as opposed to the tax accounting group. Who is their manager? And then these are just sort of fake names that make no sense. This is the date that they worked. This is that employee's name. Again, these are just sort of random strings. And then this is how many hours they worked. This is a measure of whether or not they worked on a project. So in a lot of professional service companies, like accounting companies or engineering companies, they want to know, were you working on a project for a client that we can bill? Because if you were, we need to know how much time to bill that client for. If you were not working on a project, then this would be blank or it would say no. And companies like to keep track of that sort of information so they know, okay, we have this employee, and out of the time that they worked in this month, they spent all of their time working on a project that we can bill for, or they spent some of that time what's called on the bench or not working on a billable project. So this is spreadsheet data. So we can see here in these top two rows, you have this, it's the same employee number, 89,591. So this same employee number on June 12th, they worked 1 hour on a project. June 13th, they worked 3 hours on a project. And so you'd have information like this for a whole month. This is a simplified version. And so I think I've only got about 1,000 rows of data here. But let's see. Yeah, so I've got about 1,000 rows of data here. In the real examples I've worked on with this, I've had between 12 and 15,000 rows of data. So you imagine how many employees you might have in a company. I think at the time it was a 500-person company, and you've got all this data for them for a month. So it was 12 to 15,000 rows of data. I've made this smaller. And so what we want to do here is we know that this person worked 1 hour on the 12th, and they worked 3 hours on the 13th. What we want to know is how many hours did this person work in the whole month. And then we want to know how many hours did this person work in the whole month, and then this person, no, it's the same person all the way down. And so we've got these different employees. What we want to know is how much time did each of these employees work in the month? And so we want to aggregate this data so that we can then do something else with it. And the something else is a slightly more complicated thing. And I'm not gonna show that example here, but I can point you to the code later if you want to take a look at it. So this is a fairly straightforward, well, a simpler example to demonstrate, one, how you can work with spreadsheets, but also some of the basic Python that you would use for that. So is the example clear? Or is there anyone who has questions about the example? Yes, no? All right, I'm going to move on. So this is what we have. And so like I said, what we want to do is we want to aggregate this information. And so we're going to start with some code. So this is our first chunk of code. And I'll share a link with you to a GitHub repository where all this code is. But the code files, as you can see, are numbered here, 1, 2, 3 in steps. So step 1 is this import OpenPyXL. And actually, since I see some people have laptops, let me put that link up now. So this is the GitHub repository. Okay, is there anyone who has not used GitHub before? Or is not familiar with it? Okay, so that's fine. Oh, is there anyone who has not used GitHub or is not familiar with GitHub? Okay, no, that's fine. All right, so for lack of a better term, well, GitHub is a website where you can share your code with other people. And so that's what I've done here. So if you go to this github.com/myname, you'll see, and let me just set it still. Yep, that's me. And so if you go there, then you see my beautiful face and my fat face. But then you'll see these repositories, different repositories. These are like directories where I've stored code. A lot of the stuff you don't care about, but what you are interested in is Kojo Idrissa. Well, you can just click on this repositories button, and then this will show you the repositories. It'll show you the most recent one I've worked on, which is PyCaribbean 2018, because that's where we are. And then here, so in PyCaribbean 2018, I've got some directories. This directory, Intro to Programming, this is where the code is that I'm going through now. This SEFB is from my talk yesterday. And there's a README file here that explains that. So if you look at the README file, I try to explain what's going on. But for our purposes, we want this, Intro to Programming. And if you click on that, it will take you to that directory. And so that's where the code lives. If you want all that code and my slides from yesterday, you can go back to this PyCaribbean 2018 page, and there's that green button over here that says clone or download. You can just click on that, and you can download the code if you want. So if you learn more about Git at another time, there's a thing you can do called Git cloning that will make it easier to copy it in a certain way. But for now, you can just download that information, and you can have that code to look at. No problem. And all right, so that's where the code lives. So I have it here on my machine, and so we're going to take a look at file number 1. So the first thing we're going to do is we're going to use this library called OpenPyXL, and we're importing it here. So in Python, you have this idea of libraries, code that exists outside of the core Python language, and you can import those to let you do different things. So OpenPyXL lets you work with spreadsheets, and I am going to go to that. So here's the documentation for OpenPyXL. And so it's a library that lets you work with spreadsheet data. So you can open up a spreadsheet directly, pull the information out of it, and then work in Python. Trying to avoid jumping around too much, but this is what we're doing here. So line 1, importing OpenPyXL. This might be clearer if I do it from here. So line 1, importing OpenPyXL. And then line 2, I'm also specifically importing this import workbook function. And so let me talk a little bit about how spreadsheets work, the way they're structured. You'll hear these three terms, and I think I've got them highlighted here. Here on line 8, workbook, then worksheet, and then cell. So when you're looking at a spreadsheet, when people say, oh, send me your spreadsheet, the whole file itself is called a workbook. And so this entire file, this intro to programming.xlsx, you see at the top, that is the workbook. Each of these individual tabs, and it's a little hard to see at the bottom, but each of these individual tabs, this one called clean data, and this one called K-pop draft roster, each of those tabs is a worksheet. A worksheet lives inside a workbook, just like a sheet or a page inside of a book. And then each worksheet is made up of individual cells. So this cell, B3, has the text that says secret in it. And so I point that out because when you're working with OpenPyXL, it has these different data types that it gives you. A data type for a workbook, a data type for a worksheet, and then a different data type for a cell. And that lets you do different things. And I can't get into detail about all of them, but those are the basic constructs. And so that's what's happening here in lines 1 and 2. We're importing the ability to work with the workbooks and then also the worksheets in the cells. And the code comments are making an effort to explain that. So here, I'm making this variable. So in Python, you can assign values to things. So here, this WB is for workbook, and so I'm creating a workbook variable. And to do that, I'm using the OpenPyXL that I imported before, and then this dot notation means I'm getting a method from the OpenPyXL library that I imported, and the method I'm getting is load workbook. And as the name suggests, it lets me load a workbook. So I'm going to load in data from a workbook. But then it needs to know, well, what workbook, Kojo? And the workbook is intro to programming.xlsx. And you'll notice here, you notice a couple of things here. One, how load workbook is blue, but then intro to programming.xlsx is yellow. This is my text editor. This is Sublime Text. It does what's called syntax highlighting. And so it makes different things, different colors to help you understand that, oh, there's something different happening here. So the blue is telling me that this is one of the functions or one of the methods that's built in to this OpenPyXL object. And then the yellow is telling me that this is a string that's being passed along. So these single quotation marks that are here on line 6 that are around the name of the file, those make this a string, which is a Python data type. And you use those for passing text back and forth. And so here, it's just passing the name of the file. So I'm telling it the name of the file, and then I've got this argument here, data only equals true. If you remember from yesterday morning's keynote with Luciano, when he talked about functions, this is the load workbook is a function, and inside the parentheses, I give it arguments. And so the function is load workbook, and that's fine, but it needs to know what workbook to load, like what workbook to load, and then how do I load it? It's just like if you ask someone to cook something for you. If you say to someone, cook food, okay, what food, and how do I cook it? And so you need more detail. And so that's what's happening here. I've got this function load workbook, and then I'm giving it the arguments, the detail. So the workbook to load is this intro to programming workbook, and then how do I load it? And here it's data only equals true. So if you have used a spreadsheet before, you might be familiar with the idea that in a spreadsheet, you can enter formulas. Instead of just entering like plain data, you can type in a formula. So I can say, for instance, this is probably not a great live demo. I can do 3, 5, and then here I can say equals 3 times. So I can say cell B5 times B6. So that's a formula, and it gives me an answer. When I do this load data only equals true, what it's saying is when you load the workbook, only give me the results. I don't want the form, so I just want to see 15. I don't want to see B5 times B6. And so that's what I'm doing here. And that's important because here we just want the data. We don't want the formulas because we can't use those. We just want the results. All right, so that's what's happening here. So what this does is it takes the data from the workbook, and it puts it into this WB variable. So this now is something that's in Python that we can work with. And then, but remember when we looked at the workbook, I have this clean data thing that I showed you, but then I also have this K-pop draft roster. I'm not going to use that, and so I don't want all of that. I just want one worksheet from the workbook. And so here, I'm calling it demo worksheet. And so the demo worksheet that I'm going to use for the demonstration equals workbook dot, and then I'm using this other method, get sheet by name. And and for those of you who are new to programming, when you're writing functions or using variables, creating variables, try to give them the best names you can. It can be difficult, but it's important. So for instance here, what's your name? Isa. So what do you think get sheet by name does? What do you think that function does? Yes, it's not a trick. Exactly. So she says it's getting one worksheet from the workbook. And so it's getting the sheet, one worksheet, but then again, like what worksheet? Well, get sheet by name. So it needs you to, so if you tell me the name of the worksheet, I'll go get that worksheet. And so that's what this function is doing. So it's getting the sheet by its name. And then we can see here, I'm passing it the string, clean data. Now you notice here, this string has double quotes around it, whereas this one had a single quote. In Python, you can use single quotes or double quotes to make a string, either way. And so I'm getting the sheet by name, and it's the clean data sheet. And if we look back at the spreadsheet, you all probably can't see that because it's hard to see, but here at the bottom, the name of that spreadsheet, that worksheet is clean data. So we're not getting K-pop draft roster. We'll have to get that another time. And so that's what we're doing here in this first bit of code. So this is basically, and I named this file loading.py because that's what we're doing. We're loading the data in from the spreadsheet. So that's what's happening here. So if we go back to our Jupyter notebook, I've got a list of my different files here. And let me do this. So this is one neat feature of the Jupyter notebook. So you can run code live here. So for instance, I can do this. Wow, I'm already behind on time. I can do, say, the same thing I did before, 3 times 5. I can type that in, and then if I hold down the Shift key and press Enter, it gives me the result. The output, so input 1, output 1, so it gives me the result 15. And so any Python code you can type it and run it here in a Jupyter notebook, and that's what's nice about them. But then they also have these things called magics, which is sort of a goofy name, but it will let me load in that file. So what I want is, instead of having to, I could go over here and copy and paste this, but instead of doing that, I can just load it in from the notebook. So I can go here with this %, that's what you use to start off, it's like starting a magic spell, basically. And so I say, load, and then load what? I give it the file name. So I want to load the file that starts with a 1, and I can hit a tab here, and it will auto-complete it for me. So load 1 _ loading, and hit Shift and return, and it loads that file in for me. And so now that file's here, I can hit Shift and return again, and it will run this code. So it will import OpenPyXL, it will do all these things that I just told it to do. So Shift return, all right, and so now I should have this variable called demo worksheet, just like I should have this variable called WB for workbook. There's a function in Python called type. And let me move this up a little bit. That's better. There's a function in Python called type that will let me understand what data type is this thing. And so if I say type WB, it tells me that it's an openpyxl.workbook.workbook.workbook. So it's a workbook. It's an openpyxl workbook, which makes sense because that's what we saw before. If I do type demo worksheet, this should switch to .worksheet at the end. And it does. So that's the data type that I have here. There are 2 other functions I'm going to point out that are useful for people who are learning Python. There's the help function and then the dir function. If you remember my talk yesterday, I talked a little bit about doc strings and how the doc string is what gets used for help. So let's see. Yep. And then this dir function, so you notice here this OpenPyXL, there are these dots behind it. Each of those dots is a different attribute for that OpenPyXL thing. And so if I use this dir function, it will show me what the different methods and attributes are for an object. What that means is it will tell me what things that object can do and then what information I can find out about it. So for instance, with the workbook, for instance, if I do type dir WB, so dir for WB, which is the workbook that we made before, this will tell me all the things, and I'm going to skip these dunder functions because that's a little more complicated to go into. You might remember Luciano talking about those yesterday. But here, these are all the different things I can find out about a workbook. So is it active? I can add a named range. I can add a named style. I can close it. I can copy worksheet. Let's see. Data only. When we read the workbook and we got data only. That's what I'm looking for. Get sheet by name. So we saw earlier, we went into when I wanted the one specific worksheet from the workbook, I used this get sheet by name function. And so that's one of the functions that's available to a workbook. There's also this get sheet names. So if I don't know what sheets are in that workbook, I can run that function. So the dir function is very helpful for learning Python. And I'm also going to show you the help function. So for instance, let's take a look at that get sheet by names function. Get sheet by name. And so if you didn't know how that worked, I can type help and then workbook.getSheetByName if I want to know how that function works. And you get help on it. And so between dir and help, dir will let you know what you can do with an object, and then help will show you how to actually do it. And so those are useful if you're in the process of learning Python. All right, so we've got this worksheet. So we had a workbook and we got a worksheet. Now the next thing we want to do, and I'm going to switch it back to my text editor here, just because I think it's a little clearer to see it here. So we want to get an employee list, and we're going to use the for loop here. And so I make this construct called a set. Employee IDs equals set, and it's empty. In Python, there are a number of different data structures that you use to collect data, and one of them is a set. A set is useful because if you have a set, it's like a set in math. You can only have one of each value. So let's say I have 4 people in a class named Jorge, and then I have 4 people named Maria, and then 2 people named Juan. If I have a set of all those names, instead of having 10 names with repetitions, I'll just have Jorge, Maria, Juan, because those are the unique values. So that's what a set does. And so I'm creating this employee IDs variable here as a set because I want to collect the IDs of the employees. But if we remember the spreadsheet, I've got a lot of repetition here. And so I don't want all those repeats, I just want a set of them. And so I'm making this a set, and then I'm going to loop over it. So here I'm using a for loop. And so in Python, there's this construct of being able to loop over something. So for each item in some other item, do some stuff. And I'll explain what the do some stuff part means in a minute. But again, notice that here the for and the in are pink. And so these are like the Python keywords. Here, row is an arbitrary name I've given it, but what I'm really doing is here, notice this demo worksheets.rows. And if we go back to, let's see, dir demo worksheet, one of the options I have is rows. And so this demo worksheet.rows, this function is going to give me each row in the worksheet. And so what I'm saying is, go to this worksheet and then go through each row. And so that's what demo worksheet.rows is doing. And so this is for row, or for each row in demo worksheet.rows, do some stuff to that row. And this returns a generator object, which I don't really have time to go into, but basically what it means is instead of loading them all in at once, it's going to give me one row at a time, and that's going to save memory. And so give me a row. For each of those rows, if row 0's value is employee number, it doesn't equal employee number, then do some things. So let me explain this. Here we now have an if statement. And so before we saw in line 2, we have the for statement, which lets you sort of loop through things. So for each item you have, do something. That something, you want to make a decision. So you want to do something different based on what you have. So one of the things, when I talked about this being a generator object, this is going to give you a tuple, which is another Python data structure that keeps track of things. And you can store almost any collection of things in a tuple. Usually tuples are used when the order is important. So when a spreadsheet, the ordering of the columns is important. So what we have here in this code is if row 0 dot value equals employee num, row 0, when you have a tuple, also in Python if you have a list, they are indexed in certain ways. So the first item in your tuple is going to be considered item 0. So let me so I've created a tuple here called Kojo, and it has 3 numbers in it. 1, 2, 3. And let me insert another cell. And so if I say Kojo square bracket, nope, that's not right, square bracket 0, this is going to give me the 0th item, which is the first item in this tuple, which is 1. And if I want the last item, I can say -1, and so it gives me 3. Or if I want, say, the second item, I can just say 1, and that gives me 2. And so here in my code, if row, again, which is that row from the tuple, which is that tuple from the spreadsheet, if the 0th item in that first row in the spreadsheet, that's what I'm looking for. And so that's going to be the value in this first cell in column A. So this is the 0th item. This is item number 1. This is item 2, and so on and so forth. And so what I'm looking for is the 0th item in each row, the first item in each row, and then I'm saying dot value. So this, and so what's not so obvious here is we've seen that demo worksheets is a worksheet object. Each worksheet is made up of different cells. So when I have a row is a collection of cells. If we look at a spreadsheet, you can see that this row, say row number 3, is a collection of individual cells. A3, B3, C3, D3, and so on and so forth. So for each row, this row 0 is going to give me the first item, but that's going to be an actual cell. And so for each cell in the spreadsheet, I can get a value. And let's see. I'm going to run this code so we can look at this a little bit and see what's going on. So what we have here is, now I've run this, I'm saying, so for row 0, which is going to be a cell, dot value, if that value is not employee number, which is this string, which is the title for the spreadsheet, or the header row as we call it, if it's not that, then I want you to take that employee IDs and then add that value to the set. And so, again, we start out with employee IDs. Let me go back here where it's a little easier to see. We start out with employee IDs, which is an empty set because we want unique values. And as long as the value in that first cell in the row is not employee number, or that string employee number, meaning it's not the header, as long as it's something other than the header, employee IDs.add, I want to add that value to my set. So I have this list of unique employee IDs. I think I skipped over this. This little exclamation point and equals, you notice here, I have this equal sign. And so I'm saying employee IDs is equal to an empty set. The exclamation point in Python is like saying negation. It's like saying like no. So this means not equals. So if the value in that first cell is not equal to employee number, then do this. So add that row 0 value to my set. And so this builds this employee IDs set that we have. And so if we take a look at employee IDs, so now we have this set of the unique employee ID. So why do we need that? We need this list of unique employee IDs because we want to do some processing. Again, we want this timesheet information for each of the employees. And so it's easy to do that once you have a list of just the unique employee IDs. And we can also find out how many employees we have. That seems like it might be useful to know, yeah? And so there's a function in Python called len, which will give you the length of a variable. So this will give me the length of employee IDs, and it's 49. So I know I've got 49 employees, 49 unique numbers. And so here we move on to file 4. File 3 I'm going to have to skip over because it's a different way to do the same thing we did in file 2, but unfortunately I don't have time to get into it because I've gone a little more slowly than I should have. So here in file 4, we're going to build what's called a dictionary in Python. And we're going to use each employee number, and then we want to get the information that we have about that employee. So in Python, a dictionary is a type of data. It's a data type that is what's called a key value pair. So you have a key to identify the item, and then you have some sort of value or values attached to it. And so I am going to run this code here, and then we'll be able to look at it and have a little better explanation of it. The employee aggregate. So employee aggregate is what I'm calling this. And so these are the results we get. So what's happening here? I'm saying another for loop, for employee in employee IDs, I want to do certain things. I'm using a list comprehension here, which, again, unfortunately, I don't quite have enough time to explain. But I'm saying that for row 6 value, so the 7th value, or index number 6 in the row, and if we look at our spreadsheet, index number 6, if this is A is 0, B is 1, 2, 3, 4, 5, 6 hours worked. And so here, and then so dot value is going to give me, so row 6 is just that cell. Dot value is the actual value that's in that cell. So what I'm saying is go to that cell where the hours are, give me that value. And then for every row in demo worksheet.rows, if employee, and here we have a double equal sign. And so we see the equal like in line 4, and that's assignment, and that's saying employee aggregate is, I'm making it this empty dictionary. Here the double equals is a comparison. So this double equals is saying is the same as. So if employee is the same as row 0.value, meaning for each row there, if that employee number is the same as, let's see. So here we've got for employee and employee IDs. Remember, we made that list of employee IDs. And so if that employee number is the same as the row 0.value, then I want that value assigned to this hours list. And so this list comprehension is building a list. And so in Python, a list is like a tuple. It's a collection of things. But it's a little more flexible. So I'm creating a list of hours. So what I'm doing is for each employee, I'm going through the spreadsheet and I'm saying, okay, what's the value for their hours in this row? What's the value for hours in this row? And so I'm building this list. And let me see if I can show that to you. What is that? Hours. So this is the list of hours, excuse me, for the last employee. So this employee worked 4.5 hours, 4.5 hours, 4.5 hours, and 2 hours. So this is what that hours list is going to look like for each employee. And if we take a look at what the final thing looks like, we see what a dictionary looks like. So we have the key here, which is the employee number, and then we have another dictionary inside of it. So we know the cost center for this employee is 5509. The division they worked in is 1000. The hours that they worked are 49, and the manager that they have is this name. So all these things, except for the hours number, we know where those came from. So if you look back at the spreadsheet, you can see, okay, for this person, I can see what cost center they're in, I can see what division they're in, I can see who their manager is, but that hours number, where did that come from in my dictionary? That comes from building this list of hours here, and then later on, I do this. Hours is the sum of that hours list. So I take that list of hours, there were all those different times they worked throughout the month, and I sum those up, I add them together. So that's where that value comes from. So I'm building and if we look at Python, you can see that it's sort of put into blocks to make it a little more readable. So all the things, we have this for employee and employee IDs. For each of these employees, I want to do all these things that are in this block. Notice how this is pushed in. And so all the things that are in this block, I want them to happen for each employee in employee IDs. So for each employee, I'm going to build a list of hours for them, and then I'm going to use these set comprehensions, which is this list comprehension. I'm going to build a set because each employee should only have one cost center. Each employee should only have one division. Each employee should only have one manager. And so I'm going through, so cost center is in row position index 1. If we go back and look at the spreadsheet, row index 1, row index 2 is the division, row index 3 is the manager. If we go back and look at our spreadsheet, we see index 0, index 1, cost center, index 2, division, index 3, manager. So I'm just pulling those values out for each row. And the curly brackets you see here mean that I'm building a set because I only want one unique value for each employee. So each employee should only have one of each of these things, but they will have more than 1 hour. That's why I'm using a list here and sets here. This is just some testing to make sure that things are the same. The length of cost center, division, and manager should be equal to 1, which is off the screen. That's not good. Is equal to 1. And then this employee aggregate, which was the empty dictionary that I made at the beginning of the file. So here in line 4, this employee aggregate. Once I've done all these things, I say employee aggregate, and then I give it a key, which is the employee number. And so for a dictionary, these square brackets, here for a list or for a tuple, the square brackets mean I want the index, or what position in the list, or what position in the tuple. For a dictionary, which is a different data type, it's a set of key pair values. Here, I'm assigning the key for that dictionary. And in this case, the key is the employee number. So how do I identify this employee? So I want this unique employee key, the employee number, to be the key, and then the value I want, I'm setting it equals to, the value is, and then the value is going to be a dictionary because I'm using these curly braces. For the value, I want the hours. And so the key is hours, the value is the sum of those hours, and then I want another key, another internal key that's cost center, and then that's a list of the value for cost center, index 0, then I want the division and the manager. So I'm building this structure, so for every employee, I know how many hours they worked, what cost center they worked in, what division they worked for, and what manager they have. And that's what we get. That's what we get here. So here's the employee number as the key, and then the values are these other key value pairs. So it's a dictionary inside of a dictionary. which seems a little bit confusing, but it's also a good way to organize information. So like for each person, everyone has like a registration number, an identification number. So I want to know some things about you. So what's your name? Isa. And then maybe your, what district of the city do you live in? So key might be district, and then the string of the name of the district of the city you live in. And then maybe, your parents' name or your address or something like that. In this case, we're looking at employee information. So that is what we have. And so now we have this information aggregated in a way that we can actually work with in Python instead of these Python constructs. So next, what do we want to do? So we need this information to be in a spreadsheet. We got this information, this raw information in a spreadsheet. We need the processed information to also be in a spreadsheet because we have to give it to our boss or something, or someone's boss. Someone wants a spreadsheet. So now I have to write this information out to a spreadsheet. So here, we use OpenPython, this output book. This is the workbook that we're going to have as our output. And again, we use that same workbook module that we used before. So this output workbook is just going to be of type workbook. And then the output sheet, again, each workbook needs to have worksheets in it. And so the output sheet that we want is going to be outputbook.createSheet. So this is a method that was inside the workbook module before. So I can create a sheet, but again, it's a function. We see it's blue, it's a function. Well, what do I call that sheet? And so I can give the sheet a name here inside the string. So I'm going to call it aggregate time. And then this extra argument 0, this is the position in the workbook. So when you see a workbook, you see one sheet that's first and then another sheet that's later. The 0 position means it's the first sheet in the workbook. And then, since we're dealing with a spreadsheet, we want it to sort of look a certain way. And so I'm building this header so that, just like in this worksheet, we have this, no, wrong one. Well, this one works too. We have this header information across the top. So that when we write the data and people don't have to guess, well, what's in this column? What's in this column? We want that to be clear. So here I'm building a header, and I'm doing it by going to the demo worksheet. And before I read the individual rows in and process the rows, you can also go to a specific cell in the worksheet. So in most spreadsheets, you have letters across the top that identify the columns and numbers that go along the side that identify each row. So here, for instance, the first cell is A1. Notice like the A and the 1 are lit up blue. So with A1, and then this cell is C5. And so you can go to specific cells in a spreadsheet, in a worksheet, and pull those out. And that's what I'm doing here. So I'm building this header, and so I just want what's in that first row. So I want the values from A1, B1, C1, D1, and G1, because those are the values that I'm writing into my output sheet. So I'm going to worksheet, cell A1, passing it a string for the index there, and then dot value. So give me that value from that demo worksheet. And then, once I built that header, create the output data construct. So this output data is an empty list. And then the first thing I do is, with a list, you can do something called append to add things to it. The first thing I add to that list is this header list, so appending the header to it. And so that's going to be basically the first row in my output spreadsheet. It's going to be the header, the labels for it. And then, once I've got my header row with the labels, I'm going to add the new rows in. And so, again, for employee, in employee aggregate, this is that dictionary that we just built, the one that has the key of the employee number and then the employee information as the values. I'm going to build this empty new row, and again, we've got another for loop here. So for each employee in this employee aggregate that we built. And then notice this is indented, so for every employee, these are the things that are going to happen. Build a new row, which is an empty list, and then append these different things to that list. So I start by appending the employee, which is the employee number, and then I'm going to append this employee aggregate, the key being employee, because this is a dictionary, employee aggregate's a dictionary, So using the key of employee, so that employee number, and then I want the cost center for that employee. So again, if we look back at file 4, we have in this employee aggregate, we have hours, we have a cost center, we have a division manager, and we have a manager. So I'm assigning those values by their keys to this new row. So I'm appending or adding those on to this new row. And then when I'm done appending those things to the new row, I'm taking the output data, which is this empty list, and I'm appending that new row to the output data. So I'm building these new rows in the spreadsheet in this Python construct. So when I'm done, I have this output data construct that should be what should look like each row in a spreadsheet. And so let me run that. Oh, no, that's not what I want. Oh, there we go. So I can show you the output data. Okay. Store data. Maybe I didn't run this code yet. So notice here, I have an error, name error. It says name output data is not defined. Reading errors in Python is also a good way to learn. So this name is not defined because I haven't run this code yet. This code here, this is the code file number 5. I haven't actually run this code yet. And so there's no output data. So I will run this code. And now, output data. Ta-da. And so this is what I have now for output data. So I've got this header list, the employee number, cost center, blah, blah, blah. And then I have each individual row. So for each employee, I have their cost center, their division, their manager, and then the total number of hours they worked. So there's my output data. It is a list of lists. You can do that. You can put a list inside a list, or you can put many lists inside a list. So this is what's called a nested list. And you'll notice this looks similar to a spreadsheet. Not exactly, but fairly similar. So that's what we've done here with step number 5. Step number 6 is where it all comes together, where you write this to a spreadsheet object. So now you've done these calculations, but what you want as a result is an actual spreadsheet, because you need to give this spreadsheet to your boss or to someone else's boss. So what we're going to do is we're going to use the for loop again, and just like we did before, we're going to iterate through this output data thing that we made. So we just made this list output data where we have all these rows, all these individual lists. And so for every row in output data, and this is where it gets a little bit tricky, I have to use this row index. And so output data.index, .index is a built-in Python function that will let you find out. So remember when we're using like these index numbers like 0 and 1 and 2, this .index function will let you get that specific index number, because sometimes you need that. In this case, we need it because of the difference between Python and spreadsheet. So I'm getting this row index, and then I'm doing another for loop. And so I'm saying for every column within a specific range, this range gives you a range of numbers. It's another function, a built-in Python function. And you can tell it, okay, what range of numbers do I want to use? Here, I want the length of row 0 for output data. And so that's just the header row, because I know that the data I have is the same length as the header. I have that many items. And so remember when we looked at the length function before to see how many employees there were? And it told me there were 49 employees. I can do the same thing. The row that I want is this row index plus 1. And then the column that I want is this col, which is here, plus 1. So col here is, again, is that range number. So the length of this. And so I need that col plus 1. And so this is what this is going to give me is it's going to say, you know, row number, at the beginning, row number 1, column number 1. and so on and so forth. And so for this cell with this row and column value, dot value, so what value do I want to go into that specific cell? I want it to be output data, row index, and column. And so this is going to let me read from that output data list that I got. And it will go to the specific row, so which list in that nested list, and then which column there. So what that's going to look like is this. So that specific, so for the first one, when it goes through, this will be the first row, and then the item, this will be the first column, this will be the second column, this will be the third column, fourth column, and fifth column in that first row. And then it'll go to the second row and get the first column in that row, the second column in that row, third column in that row, so on and so forth, and it will write out the spreadsheet that way. And that's why we have this nested list. So for each row, each of those nested lists, it'll do one thing, and then for each column inside that list, it'll do the other thing. And so it will actually write out those values. Make this a little easier to read. Well, it's a little bit long, so. And so that's what's happening here. It's just stepping through that list and writing those values into the spreadsheet. And let me run this code so I don't forget, like I did last time. And hide that. There we go. So I'll run that. And now, let me also point out here line number 9. This is one of the most important lines. So we've done all this stuff and we've written all this stuff out, right? However, this is all just in memory. Until you do this line number 9, outputbook.save, and then you give it a file name, until you do this, you don't have a spreadsheet. You just have some stuff in memory. And so this is important. You have to make sure you save it, and then again, so this is the save function, and then here's the argument. Okay, you want me to save this, but like, where? Just like save it just someplace and hope you find it? Well, no, like, what am I going to call this? And so I've called it done_PyCaribbean because that's where we are. So, but this is very important. You can do all the work in the world, but if you don't actually do the saving thing, you don't have a spreadsheet to give to someone's boss. So I run that code, and I can't show you the spreadsheet here in OpenPyXL, in the Jupyter Notebook, but I can do sort of the next best thing. Let's see. This is, if you're familiar with Unix or Linux, this ls command means list, and it shows you the things that are in a directory. And actually, that's what I did earlier. If I do ls now, ls-as, so I can do ls now, and so notice, so this, I ran this last night. When I run ls now, this will go away, this aggregate time, because we haven't done this yet. But then this will still be here. So I'm going to run this. Notice the aggregate time went away. I've still got those files there. And then done PyCaribbean is here. If I add this -al, this is going to show me more detailed information about the list of files that are here. And we can see the done PyCaribbean, the time on February 18th, 12:24. What time is it? So this just happened 2 minutes ago. So this is the new version that we've just made. So that is it. So now we have our file, and we can actually look at that spreadsheet and see what it looks like. So if I open that spreadsheet, voila. And so now we have, a little bit goofy, we have each employee number, their cost center, and the hours that they worked. And we can also see that if we look back at our, where did I put it? If we look at our results from, where are they? Here we are. If we look at our results from output data, we see it's the same data. So this employee 899591 worked 160 hours. They're the first one, 899591 worked 160 hours, so on and so forth. So we can double check that and see that we have the same data. And so now we have this spreadsheet that shows how much time each employee worked, and we can now give this to somebody's boss. We can also look and see that, notice it goes to column 50, but we only had 49 employees. The first column is the header. I'm sorry, row 50. The first row here is the header. So row number 1 is the header. It ends at row 50. That's the 49th row, and so those are the 49 employees that we had before. So now we can give this to someone's boss because that's why we did this. Just got a couple minutes left. I'll show you one last thing. Is anyone familiar with JSON? Okay. That's why I know you. And so for those of you who are not familiar, JSON is something that will come up. It stands for JavaScript Object Notation, and it's something that's used to pass information back and forth. And so, and depending on where you are in your programming career, you might hear about, oh, use a web API and it will send you JSON. That means it's sending you information that you can use in some way. It turns out that JSON looks a lot like a Python dictionary. But again, it's a data format that's used to exchange data between programs. And so we can have this file here, and it's not super exciting to look at, but because the JSON looks exactly like the dictionary we saw before almost. But I can use this, import JSON, and then I can say, with open, I can use this, create this aggregate time.json file, and then this is saying, write it, and it will do json.dump of that employee aggregate. And this actually looks a little bit better in the text editor because the colors are there. The syntax I think is better. So I can import the JSON module, which is the built-in module in Python, which lets you work with JSON. And then I can say, open a file. What do I call the file? Call the file aggregate_time.json because it's a JSON file. And then this W means I want it in write mode. I'm opening that as this F, a file object. And then I can do json.dump. So I import a JSON. This .dump is a function that the JSON module has. I can dump this employee aggregate, that dictionary that we made, where each key is an employee number, and then the values are information about that employee. I can dump that information into this file, and then I can give it some other options. Sort keys equals true means I can have that sorted by the keys, so it will be sorted by the employee numbers. And then indent equals 4 just means how far it's indented, so it makes it a little nicer to look at, to read. So if we look at the dictionary that I showed you earlier, where is it? It's a little ugly. Actually, you know what? Let's do this. Employee aggregate. So if we look at that, it's a little goofy to read. But if I now do this, if I run this code, now I have, if we go back to the ls again, hard to type with one hand, we have the aggregate time.json created at 12:30, which is just now. So if we look at this in my text editor, we see it's got a little bit of indentation, it's a little easier to read. So this is the JSON file, so you can send this JSON to someone else so they have this information if they need to work with it. So I know there's sort of a lot happening there, and I went through it kind of quickly, but if nothing else, I hope this will give you a basic idea of, one, how you can work with spreadsheets, but then two, just some basic Python data structures, how you would use them and why you would use them. So again, this code is available on GitHub, and you can download it. If you have any questions, you can reach me on Twitter. I'm Transition on Twitter. And I know it's time to go to lunch, and everybody wants to eat, but I'll be around throughout the rest of the conference, so if you have questions for me, I'm the tall man in the red hat. So there you go. Thank you for your time.